All right, there we go. Welcome back to pac-man cloning day 2 using zig+raylib ECS. Okay, so let's continue. So this is how we got so far. We have our maze encoded in like a in-memory kind of layout that we draw onto the screen. And we also have our little pac-man moving around. Yeah, so I think last time I was working on the grid, like the collision, so you can move around without, you know, facing through walls. Hello, Blue. What's up? What's up? So yeah, I think that's where we left off last time. And I'll just import grid here so we have it. No, it's not public. Okay, so now we get stuff happening in here. Okay, so let's see. Well, yeah, I was working on this resolve collisions thing. And we also have this axis that we need to figure out one axis at a time. And we have this calculation here where actually this could be comp time. Now what that does is you're basically, I think what's going to happen is you're creating like several versions of the function, where one version, because axis is comp time, so like the original, like the parameter into the function is comp time here. So that means if you pass in x, you will get this version. If passing y, we get this version. It's not gonna run this in runtime. It's gonna be selecting which function you want based on comp time here. Are you gonna make a 2D array with 0, 1? Pac-man can only move 0. Not a 2D array. This is a 1D. So I have this grid, which is what I'm gonna use for collision detection. I have a 1D array that I'm simply translating, you know, x and y coordinates into an index into this 1D array. Just because it's simpler to kind of create this 1D array. You just create it like this, so you take like the number of cells is going to be width times height, and then to get the coordinate you take x plus y times the width. So yeah, it's not, yeah, but anyway, so what we do is we calculate the hitbox for the thing that we're checking against. For the body, we have the we also calculate what is the grid coordinates of the box, of the hitbox, where we take the min hitbox here and the max, and we check like, okay, we're colliding with all of these cells, so those are the cells we want to check, essentially. Now I just realized also that we don't really, I was checking for collisions against the rects as well, hitbox against cell hitbox, but we don't really need to do that because we already know that hitbox is inside of the cells, so we don't actually need to do that. So I'm just gonna get rid of this if here because it's always gonna be true. So because we already calculate which, like that's kind of the thing here, is like you calculate which cells you collide with here, basically. And then as we go through that, we know that we already collide with these cells, so we don't need to check that again. Wait, so you have to implement searching algorithm like DFS, BFS for Ghost. I'm not sure how the ghosts work. I think we'll figure it out. And it could be the case that it would have been maybe good if I did this another way, which can both the ghost and the pac-man actually utilize, because they are, the pac-man kind of changes behavior a little bit when you're at an intersection. The same with ghosts, because they decide to take a turn or not. So it's kind of like, somehow they know that they are at an intersection. Because if you're at an intersection with the pac-man, but you're not exactly centered, and you want to make a turn, but you're not exactly centered onto the next road, if you press to turn, pac-man will actually like glide into that intersection. And and the ghost will like make a decision. So both pac-man and the ghost have like their behavior kind of changes depending on if you're at an intersection or not. So that is kind of central to this system as well. But we could just make it. We could just do. Either we could mark all intersections, or we could calculate them, or we could, whatever we do, we could produce a bunch of intersection like, hitboxes. And if you're at an intersection, that then a ghost will decide to turn, or pac-man will be able to move up or down or whatever. So yeah, we'll figure it out. But for now, I just want this basic collision stuff to work here. Okay, so let's see. So the hitbox, the cell hitbox, I'm not sure if we even use this now. Okay, we do. So yeah, we did this whole thing here. So I think we are technically done here with... the only thing we don't do is we should also abort the correction here, I think. Because once we've done one of these, once we've collided with one cell, we shouldn't check the other ones, I don't think. Yeah, let's just try it. Let's try and abort this here. So if we found one, we return. And then we don't actually need to look through. Well, we do need to look through, because we need to look for the first one that is solid. That's right. Actually, maybe what we could do, like to make this more precise, is to take the one that is... I don't know. That we're like colliding with the most or something. I don't know. Or the least, maybe. I don't know. Anyway, let's just do it like this. Okay, so let's now we need to go into the physics system, because the physics system also needs to have the axis when we update. So we will do like this. So basically, velocity can just be changed, that's fine. But when we make position change, that's what we need to worry about. So I'm gonna do first, I'm gonna do a function here, update positions or position. We're gonna have a body. We're gonna have an axis, which is comp time. Now this is gonna be like grid.axis, I think. Yeah. And then void. Alright, we also need game for delta time. So basically this, except we don't update position, we update based on axis. So it's like switch comp time axis. If it's X, we're gonna do X. So position X, position X. Now we can just use plus velocity X times delta time. Okay, and for Y, we essentially can just replace X with Y. Okay. Now, instead of doing this, we will do first update position on X. Okay, so now just X is updated. Hello, Penguin. Welcome. And then how are you doing, by the way? And then let's see, update position X. Yeah, and then we now we need a grid. So I'm gonna add grid here. It's gonna be something I guess we put in here, perhaps. Yeah. So we'll create a grid, we'll pass it into the physics system. That's the grid we're using. We can change it later if we want as well. And now we can just say self grid. Now we actually need self over here. So self grid. And now we can resolve collisions. And we resolve collisions for X. Okay, and then we do the same thing except for Y. There we go. And I don't remember if there's any difference if we change, like if we do Y first, like the order of these operations. So if you do X first, X will be corrected first. So basically you move, let's say you move to the left, X will be, you're bumping into a wall, you will be corrected to X. And then Y, you don't move in that direction, so nothing happens there. But if you move, let's say down left, then you will, and you're in a corner, let's say, and you're in a corner, then X gets corrected first. You're bumping into the wall on the left side, and then you go down, and then you're bumping into the wall on the bottom side, so they get corrected again. So that should work. And if you're moving into a wall, you're gonna like move X first, bump into the wall, correct X. Y is then not colliding, so you're gonna be able to glide or slide against the wall. And also we have these events, that's right. Now the events, So basically we can get up to, I guess, 2 events. The thing is, like, the events, it should really just be 1 event per frame. Like, you couldn't, or, Actually, the pellets, we don't know if we're touching a pellet here. Oh yeah, I think I added pellet here because the reason is, like, there's gonna be a lot of pellets, so brute forcing the pellets might be very inefficient. So I wanted to put them into the grid system as well. So then each cell could have a pellet. But anyway, I'll figure it out later. That's a future problem. I'm just gonna ignore these for now. I'm gonna ignore these events for now. I just want the basic collision to work right now. This is unused. Oh, I don't know what happened there. There we go. Okay, now we get a bunch of stuff happening here. So you are comp type int, ambiguous, division. Well, you know what we'll do? Instead of doing this, we'll do I think I want to do this. It's gonna be x over that. Is that better? Probably. And then x, and then we floor it. Actually, we could just do div floor. Min is div floor floor. Floor. Okay. And then you are max. Yeah, you're just same thing. Hitbox max x. And y. Okay. And now instead of doing this, we can do this. But I am actually a bit confused now, because these are floats, so I'm pretty sure this won't work here. Yeah, expected usize found float. So what we do is we make all of these usize, and then we will do int from float. And now they can all be const, because we're not changing them. Okay, and the hitbox, yeah, so let's do float from int here. Oops. Collision event, I guess it could either be nullable or we put just a none here. For now. And also at the end, we also return none. Okay. Q. Expected one argument found 0. Right, so now we also need to now construct the grid. I'm gonna make a function for this. I'm gonna create the grid here. Yeah, you just get a grid. Get a grid. This will return a grid that we import. Okay. So let's see what dimensions did we have? I think we have that in Maze. We have the dimensions. Well, this dimension is actually not correct though, because it's the maze is like here and not somewhere else. Although we could technically choose the same dimensions as the screen though. So this would be 36 by 28. 36 by 28, that sounds good. So width is 36. No, that's the height. 28, 36. Okay. And then we have the data. It's going to be allocate cells width times height. I'm just going to catch up reachable. Okay. Right, so now we have some data stored. I'm just gonna add the I'm gonna add the init function for physics so we don't forget this here. Oh, I see. We already kind of do this here. Okay. Well. Wait, do we already have the init? No, we don't. Then we're gonna do allocator free cell data. Because yeah, that's good. And that's there, and then we do, where's the game, deinitialize, we get the physics. And we're gonna deinitialize. All right. Because otherwise we get like a memory error at the end, which takes like longer to like exit the application and stuff. But let's see. Yes. Well, okay. So actually, we don't really need to do that. I guess we could just create the grid like this. And you need width is 28, height is 36. Okay, and then we return this grid. But now we need to. So we have the basic grid here. We need to modify it though. Actually, I could put const here because the thing we actually modify is a pointer to a mutable. So even though the grid itself is constant, this pointer is where it points to is not constant, so we can go ahead and mutate that. That can be a little bit confusing about the concepts of this, but yeah. Because you would think like, yeah, constant, you can make sure that anything in there won't change, but that's not actually the case sometimes when you have pointers. Depends on kind of how you interpret or use the things. Anyway, so I'm thinking that we do have like the maze. We have the maze layout and stuff. So this was what? It's a rectangle. Oh yeah, these are source rectangles, that's right. We could also go through the string. We also could change this out from just rectangles into a maze cell that has more information, so it's easier to work with as well. So we can make a cell here, and we can have the source is a rectangle, and then we can have like, I don't know, is solid, is, we could even have like is intersection, stuff like that, like is open, so we could have that information encoded in here. Let's just have this for now. We can add more later. And what we want to do then is we want this to be cells instead. And you're going to be cell. But when we create the cell, let's create an init function here. Source is solid. No, and then we get this cell here. All right, and then here we do. Actually, this could be a cell. Oh yeah. So actually, okay. So these ones could be cells directly then. Actually. So all of these, I'm just gonna do, because most of them are gonna be just like this. So it's gonna be like cell.init, and then that's the source, and then is solid is gonna be true. That's the case for most of these. So I'm just gonna change these into cells. The only thing that's not true is this one here. You're not solid. And then these ones are just aliases, so I don't need to do anything with that. But there we go. So now all of them are cells instead. Shadows declaration of source. Okay. Okay. So now the maze layout is actually a bunch of cells instead of just source rectangles. So now we can get more information. So now we can say the grid data. So essentially I wanna loop through. Since both are like one-dimensional arrays, we can just do from width times height. We get an index, and we can say grid data I is equal to, and basically we only have like a solid here. It's equal to maze layout I is solid. And there we go. Now we should have that information as a grid. And let's see what's happening here. Right. So now these are not sources, they are actually a cell. And to get the source, we just say cell.source. Okay, let's see if this works now, because we've connected in the grid, we're creating the grid, we're putting it into the physics system. The physics system is updating the position, and then the cell, which we can see here kind of works, kind of doesn't work as well. Also, we get a crash. Okay, I kind of know why this happens. Well, the crash anyways. The crash happens because we are basically moving outside of the grid, and that causes us to try to access something that doesn't exist, which happens over here. So X and Y at this point is like outside of the grid. So what I'm gonna do, and that will cause this index to fail, be outside of that. So, and then we crash. So what I'm gonna do is I'm gonna make these. I'm gonna make this mutable again. I'm gonna make a function that clamps an F32, clamp X to grid, actually, there we go. And then we're just gonna return maximum. So the maximum can be 0. Since they are F32s, we're converting to a U size, which is unsigned. So that can't be negative. We have to do 0 here. So we might change this later because it's gonna wrap around as well. So I'm not sure exactly how we're gonna do that. But we might do the same trick as we did with asteroids, where there's a little border that is not solid on the outside that you can actually walk through or something like that. I don't know. We'll see. Max is gonna be, or there's a special maybe animation or something. I don't know. So max, and then we also need min, because we need to guard for the other side as well, and that's gonna be the width minus 1. Actually, we need to convert width to float, so I'm gonna make an f width float from int here. So, and we need to minus 1 because of because otherwise we would be beyond the end there. That's just how the math works out there. So there we go, and then clamp y, and now everything that's called a width should be called a height. Okay, so there we go. Now we have these clamping functions, so we make sure that we don't go outside of the grid, and then later we won't fail at indexing. So this will be clamp x to grid, and then y is clamp y to grid, and then we do the same for max. Okay, so there we go. So now those should be modified to always be inside the grid. However, this could mean that we basically have a rectangle of 0, let's say, if we're fully outside the grid. Which shouldn't really happen in Pac-Man, but because, well, maybe it happens. I don't know. We'll see. I'm just gonna do like if max grid x minus position x is less than or is equal to 0, or max y minus min y is equal to 0, then we have like a 0 area, so we can just return at that point, or continue. I mean, we can continue here to the next one. Okay. Wait. Oh, you're a U size. Oh. Oh yeah, we need to do this before, right? Yes. So actually, we need to do this here, because we need it to be a floating point before. Clamp y to grid. Clamp x to grid. And clamp y to grid. Okay, yeah, so back to them being constants here. A lot of stuff happening in here, but yeah, I'm basically turning them from floats to integers at the same time as converting from x to, or converting from pixel coordinates to grid coordinates, making sure it's inside the grid, converting to float, or I mean to an integer from float. All right. Okay, let's see if this works here. I could put that into a function or something or whatever, but whatever. Okay, there we go. Now we can be outside of the grid and we won't, yeah. So anyway, you can see that there's an issue here. I can't, like this seems to work here. I can't move past up here. I'm trying to go up, but we can't, I can't. But if I approach from, I guess, the top here. I can see the coordinates where I am. So I'm gonna hypothesize that I'm gonna be able to warp through here. Yes. But if I try to move up, I can't. If I try to move left, I can't. So up and left seems to work, but down and right we seem to warp through. Okay? So that indicates that there is some kind of polarity issue or something with this part here, where we actually correct. Actually, first, yeah, it should be the correction that's the issue. So should we just add here? Like, I'm confused. I need to work through this because this should be negative if. So this is basically a distance between the left of the body and right of the cell. And this is the distance between the right of the body and left of the cell. So left of the body, right of the cell. That means that, yeah, this is negative if we collide. Right of the body, left of the cell. Right of the body, left of the cell. So that means that this is like lower. Yeah, this is larger than this. So this would be positive. So I was thinking this the other way around, actually. This should be on the other side. So it should be like this. If it was like how I was thinking there. So now this should be negative if they collide. And now this should be correct. So when I move now into a wall from the right, or well, depending on which perspective you have, I should not be able to go through the wall. Okay, that's. I mean, it looks more correct, I guess. You can't go past, but it still is kind of weird. Maybe we should just do abs. Why do we go back so far? So in that scenario, you would go into the cell. It almost looks like we don't actually collide until. Okay, let's do this as well. Let's do draw. I'm gonna draw. When we draw the maze, I'm also gonna say, okay, we draw the position. If the cell is solid, we're also gonna draw like a background. So draw rectangle. Position. Size is, well, I know the size is 8 by 8, so I'm just gonna say it. And this one is, I'm just gonna say like dark gray or something. Okay, so we're basically filling in all the solid areas. Or not. What the hell? Oh, I know what's going on. It's because the sprites, the black thing is not. Okay, I know what's going on there. Now, okay, let's just do it like this. Yeah, so the sprites, I forgot to copy this over before, because the sprites are, yeah, now we have the transparency of the sprites are like implemented. So I forgot to update the file there. Okay, so we have a bunch of these things here now, but you can see that it's kind of weird because we're actually going almost inside. It's like the center position. Okay, so is the origin incorrect? Draw render roles. I'm gonna draw the hitbox. Actually, draw rectangle rec. Because this is just a rectangle. Color, just gonna pick red. Okay. So, yeah, okay, so the hitbox is actually, like, correct. What hitbox are we using over here? We are using this hitbox, the same hitbox. So I am confused. I'm very confused. Okay, what we could do is we could say let's do get cell candidates. So what I'm gonna do here is I'm gonna get candidates. This I will actually I will just return a rectangle actually. The rectangle represents like the min max. It will represent these values here, min max here. So so you would be able to get those things, and then we pass in entity context. Okay, so essentially this is what we're gonna do here. And then we return min grid position x, min grid position y. And then this we would have to take max x minus min x, max y minus min y, because that's the size there. Okay, so there we go. Now we have those there. Oh, we also need gain. Okay, fine. We could also just provide a hitbox. Actually, we could just provide a rectangle. Actually. So now instead of doing all this crap, we can say grid hitbox is gonna be get cell candidates. Okay, and then now we can simply check like grid hitbox. So if either the width is 0 or the height is 0, we can just return 0. Actually, you know what? Maybe a rectangle is bad because the rectangle is not U size. Actually, we want our own like U size rectangle. Sort of. Or just the min and max directly, maybe. Because here we need them as U size. Ah. God damn it. But in the other place we don't. Okay, well. Cell candidates. Yeah, let's just put them like this. Alright, so I'm gonna say candidates. And we can also say has candidates or something, I don't know. You know what, let's just do width, height. Yeah, we could do it like this, actually. Actually, we could do like 2 rectangle. Because that we can use in both places. Because I want to draw this as well as use it otherwise here. So x will be, well, we could just do init self min x, self min y, self max x minus self min x, and max y, y. There we go. And then we just have the rectangle, and we can say rec width is 0 or rec height 0. Then we return false, otherwise we return true. Or let's call this is empty, I guess. And here we can simply say if candidates is empty, then we continue. Okay, because now we can use this here. Right. All of these need to have int, no, float from int. Okay, so now we can go here and we can say grid candidates is going to be, well, we need physics. Physics grid get cell candidates hitbox and then let's see, grid candidates Right, so now I want to draw that. I can say to rectangle. Now we have a rectangle, and we can just draw this rectangle. So draw rectangle, and it's gonna be this grid candidates. The color will be, I don't know, yellow. All right. So now we should be drawing whatever candidates are like considered in the grid for this renderable, or not. Oh, I can see at the top left. Okay, you can kind of see there. Do you see at the top left? There's a little dot moving around. Okay, that is the... Okay, so we need to scale it up. We need to scale it up. So... To scale rectangle. X is times equal to cell size. Width and height. Everything is scaled. Then we return X. All right. Now I hope we should see it now. Okay, so there you go. The calculation is wrong. Also, I'm not sure why the collision doesn't work at all now, but there we go. So we have a couple of issues. It seems like it only picks like the top left, and then it doesn't pick the rest. So, because we should see like these over here, 4 candidates over here. This is just 1 or potentially 4, maybe. I don't know. Yeah, it's 4 actually. It's actually kind of... Yeah, it's interesting. It's like it's picking the actual center of the sprite instead of... Like the body position is the center. Which is strange to me, because the hitbox should be... Yeah, we're printing out the hitbox. And... Okay, let's look at how we calculate these here. Wait. Oh, okay. So here's the issue. We do a div floor here. We should do a ceiling, actually. But there's no div ceiling, unfortunately. Because that would be very convenient here. But we can do a div, a normal div. Just divide like this. And then we can change this to a ceiling like this. Whoops. And hopefully that will work. Okay, let's see how this looks now. Okay, there we go. Now we're properly picking all the correct candidates. So essentially, all of the things you see in yellow are the ones we're kind of colliding with at the moment. Right? The trouble is also, you can see already that this system will kind of fail, because the cells that are drawing the maze shouldn't actually collide like that. Because yeah, you should be able to get stuck in between here. I mean, I guess what we could do, we could change the collision size of Pac-Man to 8x8 as well. So okay, let's try and do that. I'm gonna say, okay, I'm gonna do this. I'm just gonna make a special component called hitbox. Which will essentially just have the actual hitbox, relative hitbox here. Okay. And then in setup, when we create the player, we're gonna add a hitbox. Oh yeah, we need a hitbox here. Hitbox init. So 0, 0, and then 8x8. Okay. And then when we call hitbox from game here, we are going to check first if we have a hitbox. Try get hitbox. If we have one, we can use it. If we don't have one, we will do all this crap over here. But if we have a hitbox, well, we also need to get the body, so I'm gonna move this out here. We're gonna return body position X plus hitbox X, body position Y. Actually, let's make this a copy, and we'll just change X to be plus equals. And then we just return hitbox here. Okay. Wait, so this is the component. Okay, I'm just gonna call you hitbox component then. And then we're gonna do result is hitbox component dot hitbox. There we go. Okay. Now there we go. So there we go. So now if someone has a hitbox component, we're gonna try and get that first. If we have it, we're gonna use that. Otherwise, we're gonna calculate the hitbox from the sprite as we did before. All right, so let's see how this looks now. And I already know we probably need to align the center. Yeah. So you can see that, yeah, now the hitbox is smaller, and we only collide with basically always four at a time, unless we're perfectly aligned, which we would never be now because it's a floating point. Yeah, you can see only at the beginning. If I move perfectly left and right, it's only colliding with two. As soon as I move slightly down, we're basically always going to be colliding with 4 cells at a time. But anyway, yeah, so, but we need to move it down a little bit because the sprite is like slightly offset. So we can go back here and we can just move you down I guess half of the size. And now we should be at the center. Hopefully. Yep. So now we're at the center. Okay, so there we go. Now we have the thing sort of working there. Now we should also, I'm gonna have to look into now why is the collision not working? So let us go through that here. So we know that the candidates are pretty much, yeah, they are correct. Then it might be this empty check that could be wrong. It's like if width is 0. Actually, this should be the other way around. True or false. There we go. So it's empty if either width or height is 0, then it's empty. Otherwise, it's not empty. There we go. Always the booleans. Okay. And there we go. Now it works. Except for the down direction, but we know why that happens. We have to switch U out into here. And there we go. That should now work. Okay, there we go. The only issue here is like there's like when you try to move into an intersection, it's pretty hard to, because you have to be perfectly aligned to be able to move up. Whoops, what the hell? Why can't I move through there? That's strange. Huh. Oh, and there's a weird issue over here as well. It could have something to do with the fact that we are only checking the first cell and then exiting the collision algorithm. Could have something to do with that. It only seems to be happening in the right direction though. As far as I can tell. Oh, here it's like all weird. Okay. Yeah, and there's no way I can enter the maze now. Okay, well, it kind of works. I was thinking this should definitely work. Well, maybe not definitely, but like sliding up. So essentially, we're checking X first, right? So if we move, we slide, we go top left. It's gonna correct X first, and then it's gonna correct Y. If we change those around, no, because then Y would go back to 0, right? Maybe we could check, like, if we're in a corner, we have a little bit of leeway or something like that. Maybe we could try do something like that. I have to try and fix whatever issues are happening. It seems to only happen at certain points. Like, why is this happening over here? Is it because of the width? Okay, I might know why this is happening actually. I think I know why. It's maybe because of the clamp. Let's see, where's the clamp? It might be because of this. Because we're clamping -1. Should we clamp? Should we do this then? I was pretty sure we shouldn't. Because this would crash, right? I mean, maybe not. I don't know. No? Okay. Okay, there we go. That solved that issue. Huh. And now it doesn't go crazy down here. Except it sometimes does. Anyway, if I try to move down, it goes crazy sometimes. Interesting. It's weird because it only happens like down there. Is it because we are in between two things? No. I'm trying to do the same movement like at similar places. It only seems to happen over here. Okay, I'm gonna try. Let's see if we move like straight down. I can't even like go. Okay, I can't even get through there now. Let's try this way. Okay, so if I press up, there's no issue. If I try, as soon as I press down, this is straight down. Straight down. So what I'm gonna say is happening when we go straight down. Actually, you know what? I'll do this as well. I'll add input. I will add action move down. And that's gonna be that's gonna be like left face down. Okay, and then we go to controllable. That's happening there. We're also gonna say if input is down, move down, then we're also gonna add velocity. Y is gonna be, we're gonna add controllable speed. So we're essentially just gonna move down. I can use like my D-pad to move down as well. So I can make sure that I'm moving straight down to test this here. I'm moving straight down. Okay, so moving straight down actually causes us to go to the left. I wonder if there's like a precision error, like because we're dealing with F32. Maybe we should change the coordinates to not be floats then, and just be pixels. Or we can try to like floor or round the result as well, actually. When we collide, we can round the results. So when we adjust here, we also do round. Okay, will that fix the issue? Because changing it to like integers will probably solve the problem as well. Okay, now I don't get this issue. Cool. Because yeah, I think there was like, it moved it a little bit too high or something like that, or too low. And then you still collided with the next frame, which would cause it to move over. Yeah, okay, there we go. So now we're always like rounded. But now we have I can only turn when there's like a T intersection and I'm coming through, you know, like this. I can't turn from a straight road onto, I can't turn here. But I can if there's a corner like this, or if I'm going into a straight road like this. Because, yeah, I can't find the exact position that's happening over here. So maybe we could do it like this. We can have two different positions, maybe. We can have one position that is the floating point. That's our real position, let's say. And then we'll have an integer position. So essentially when we want to... Okay, so what we can do is we can say when we check for collisions, we are going to... we get the hitbox here. We could round this hitbox. So, yeah, that makes sense. We round the hitbox. Is there a round here? No. Let's just do it like this. Min x is round. Hitbox min x. Whoops. Y. Min max. This will be like this. Okay, so now when we check there for collisions, there we go. Okay, that actually works pretty well. Because we're rounding them to nearest integer, so it's way easier. You have like a little leeway to do that. Now, but you can also see when we try to go into a wall, you get a little jiggle. That's because we're actually drawing. We have like two different positions now. It's like the collision position is the integer pixel one, but the drawing position is like the floating one. So, but that can be easily fixed by saying that when we draw something, we're not going to draw it onto the screen using its floating point coordinates. We're going to use the pixel coordinates. So we're just going to round. We're going to round it. So let's do draw. So when we draw the renderable, we have the position. We're actually going to say basically like this: init round position x, round position y. For the position y. That should draw us at the same place where we're now colliding there. So now when I try to move up and down, it's not gonna actually, you can see the hitbox moves, but the sprite stays the same. Okay, cool. There we go. Now we can move around like this. And we can move everywhere. Awesome. Should we do like the wraparound here? I'm not exactly sure how it works in the original, but I'm just gonna make it so that whenever you go through here, you end up at the other screen. I guess we could do it so that when the hitbox, I don't mind a little bit of, you know, you can see this, the pac-man actually move, like teleport or whatever. I don't mind that. So I'm just gonna say that when you move and the left side of the hitbox is at the edge of the screen, we're just gonna teleport pac-man to the other side, or whatever body is there. So Rotate pac-man to the direction of movement. Hello, Sammy Hacker. Yeah, I'm gonna get there. Don't worry. There's a lot of small things that needs to be implemented with this game here. Small details. I also need like the animation and all that. Like, yeah, we're basically just starting out essentially. Even though I spent like 5 hours or something yesterday building the up to this point. But okay, so now let's see. We need the wraparound. So I'm gonna say apply wraparound. Is wraparound one word? Let's get. I mean, we do need like we need a hitbox, which we probably should have. We don't have the hitbox now. Okay, so we need game. Whoops. We need game and we need the entity context. Hello! How are you doing? Are you a game developer or are you just interested in watching game development? Let's see. Yeah, so essentially we get the hitbox. And we say if hitbox I'm gonna say so we're gonna do like left is hitbox dot x, right is x plus width. So if right, well, let's do left first. If left is more than, or yeah, if left is more than the size of the screen, I guess. So let's get the screen size x. Then we have moved fully outside of the screen. So then we're gonna wrap around. So we're gonna get the body. Here, get the body. And we're gonna say body position x. And we're gonna say negative equals screen size x. So there we go. So if we go out on the right side of the screen, we're gonna go all the way back to the other side. Same with right, but right is gonna be less than 0. If right is less than 0, then we're gonna add screen. So then we're gonna wrap around on the right side of the screen. And you could do the same with y, but we don't have those openings. They are just left and right. Okay, so then now we should, I'm just gonna say wraparound. Actually, we'll probably, no, we'll do a wraparound after here. Yeah. So there we go. Because even if we resolve collisions after, there's nothing really to resolve against. Okay, that didn't work. Wait, no. It's not the screen coordinates, actually. It's the pixel size. The pixel size, here we go. Yeah, because the screen is like the resolution is larger. The pixel is the actual like pixels. There we go. And you can kind of see it like the Pac-Man is kind of Maybe, okay, maybe I should not take the entire width, actually, because we kind of move in straight like that. I'm gonna do plus, so pixel size. So we're gonna do like adjust offset is gonna be pixel size X minus hitbox width, I guess +1 or something. Whoops, whoops. So that we don't, no? Wait, did I do it incorrectly? Should it be plus here instead? And then -1, wait. Yeah. Because otherwise, I think you're gonna get stuck in like an infinite loop. Okay, there we go. Looks a tiny bit better. Oh, you can actually be kind of outside there. Oh, 1 second. All right, I'm back. Sorry about that. Let's see. Why? Okay, so why can't I move like outside? So it's like that tiny sliver here where I can move outside. It's like 1 pixel wide or something. So maybe we should do left or equal, perhaps. We should only be able to get to these positions from this corridor. No, I can still move outside at a certain point. Okay. So is it like, okay, let's do, I guess 1. We'll decrease where this happens until we can't escape the maze. Oh. Okay. So let's do here -2 here. Okay, there we go. I don't think we can escape now. Okay, we can. You know what I'll do? I will implement, so let's see, input. I will add all the rest of these. And what I'm gonna do is, like, when I press one of these, it's gonna move 1 pixel. So you can use the D-pad to move 1 pixel. Up, left, oops, right. All right. So we'll change to down to pressed, and you are gonna be. Actually, if this happens, we should well. It's like we want to move up. I'm not sure exactly how fast this will go. I guess we'll just see. I could also do position, but but then that kind of doesn't work. Or does it? No, I guess we could do position. If we do else if, because we don't want to move at the same time in 2 things. Position. And we'll do 1 pixel. Okay. It could be a precision issue when pushing, like, against the wall or something. So if I press, I see. If I press up here, it actually goes into the wall. That is very strange. No, it's not, because, okay, well, god damn it. Okay, let's just do it like this then. Go back to this. So the FPS is 60, I think. Frame. Let's do like delta time. It should be 16 or something. So essentially what velocity is, it's pixels per second. So, and each frame is 16 milliseconds around. So in order to get 1 pixel, we have to do so it's 1 per second. 1 pixel per second. No, not 1 pixel per second. 1 pixel per frame is what we want. Hello Phil, what's up? 1 pixel per frame, so 60 frames. will be 1 second. Is it just 60 here? Am I tripping? Yeah, it's going good. We have like basic, we have like the collision detection working. So we can move around in the maze. And I'm working on the wraparound right now. So we can move around the maze like this. And let's see. Yeah, and then, you know, it's just the rest left. I'm trying to... Okay, there we go. I can move like up and down. If I press D-pad now, I can move like 1 pixel at a time. So we can debug this a little bit better. So if I move 1 pixel, it seems to work there. However, when I push up at the same time, there's sometimes you can like phase through here. Maybe this is like an Easter egg, because you can't actually progress when that happens, right? There's no like point in doing this, although it's gonna be annoying if you don't want it to happen and it like constantly happens or something. It's like when I try to, it's something to do with the precision here. Because the real position of Pac-Man is as stored in floats, but then the collision is like rounding them off to integers. And now I can't get back down. So it's like a weird in-between thing. I'm not sure how it happens. But maybe we'll just leave that bug in there. It's like usually you just move, but it's pretty simple to get it at the first. Like if you're just... Yeah, you simply just have to hold up and it happens. So it's kind of annoying actually. Okay, I'm gonna do one more padding. I'm just gonna call this padding. I'm gonna be 2 here. So -1 negative padding. And this will be padding here. So now, hopefully, it's not gonna trigger. We can trigger an infinite loop here though. Okay, it doesn't seem to happen now. Whoops. No, the conditions have to be exactly the same. Yeah, so that doesn't happen now, but I guess this has to be like padding times 2 or something. I don't know. Okay, there we go. So the wraparound is like, it's a little bit teleporty, but whatever. Cool. All right. I mean, we could also, well, the problem is like if I allow to move further out, there's no boundary, there's no like collision detection happening over here. Although we could add like a special check, like if the Y position, or if the X is over at here, you can't change the Y position. We can also do that. So that we kind of lock Pac-Man. Actually, let's do that. So apply wraparound. Actually, we want to say here, if no, it's gonna be the left and right. We have to actually get like hitbox. So we're gonna say like, actually we could check, we could just add a function for this. Is in wrap around corridor. Because if let's just say we have this function, if we are in the wraparound corridor, we don't want to update. So if we're not in a wraparound corridor, we should update y. If we are in the wraparound corridor, we should not actually do y. So y will basically never change when we're in the wraparound corridor. Okay. So in order to check that, we simply need to check, okay, well, are we like outside of the normal bounds of the maze? So essentially we're checking these here. I'm just gonna copy this here instead. Okay, we don't really need to change the position though. We just need to say, if we're outside here, I'm gonna remove, well, padding should go the other way now actually. Adjust offset, we don't need padding. So now we can actually add a little bit of padding. And the padding should actually be like 4 or something like this. And then, yeah. And then we're gonna say, we're not gonna change X. We're just gonna return true here. No, actually the padding should be negative here. Because yeah, because we want to detect when we're in the corridor, that's right. Okay, otherwise return false. And then over here we can simply say like, if we're in the corridor. If we're not in the corridor, we don't care. Actually, you know what? Let's do the same calculation just here. And the padding, I'm gonna say, is 4. But here we actually add padding instead, because now we allow to go outside here. Wait, no, u should be plus. Yes. Okay, I think that should be good. But now we don't need this, I don't think. Let's try this. Let's try doing it like this first. We'll see how that works. Okay, so now we should be able to go like outside of the corridor, I think. And then we end up. So you can see we're fully exiting the screen. And then we end up over here. So we need to adjust a little bit. We can add a little bit more padding. And then we can say hitbox width. Yeah. No, we need more. Huh. Well, I guess we need to add the padding as well, I guess. Yeah. But now, I think we're gonna get stuck in an infinite loop. So we might need to adjust by like 1 pixel or something. Okay. There we go. I guess it doesn't matter if we're stuck in an infinite loop, because maybe it does, actually. Let's do like -1. It doesn't have to be perfect. Like, it's just, it was just annoying that you could like escape the maze. But now we fixed that issue, I think. Why do we appear like that? Okay. Man, why do I want this to be so perfect? I don't know. We could just add a little bit more padding, I guess. We could add... Actually, let's do like hitbox width +2. That's what we have now. No, because hitbox width is 8. Okay, sure. Let's just do this. What the hell? We still end up like... Yeah, because now you need to be larger. So this needs to be like padding. What the hell does this need to be? Like, we go over by size. This length is kind of like, how much outside are we gonna go plus this? So I'm not sure why we end up like still showing like 3 pixels. Okay, you know what? Whatever. Let's just do it like this. I wish we don't like teleport in like that. You know what? Let's just count the pixels. Okay, so we're basically 4 pixels in. So that's like half the width. So I'm gonna times this by 1.5. Okay, so now we should not see ourselves poking outside there. There we go. Perfect wraparound. And we can't escape outside the maze. Cool. All right, there we go. That was that. Okay. Let's disable drawing all this crap here. So we get like proper representation here. There we go. This looks nice, right? Waka 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 waka. Okay, so now I wanna have, what do we want? Notice that I can kind of sneak as well. Like, that's not part of, that's just why, that's just like the gamepad. Does the pac-man look a little bit offset to you? Like it looks a little bit to the left. I'm not gonna worry about those details. I just want to implement the core gameplay here. Okay, let's focus on that. So now, yeah, let's do like the animation of Pac-Man. So let's look at the sprite sheet. So I think we're down here. So I think, yeah, this is like this rotated, and I think they kind of just flip the pixels or something. Is this this is a score, maybe? The score or the extra lives, maybe here. Yeah, and then we have a bunch of stuff as well. And this is a death animation here. But let's do like these things here. I think I'm gonna bring in probably the animation struct that we had in the previous game. I'm not sure which one that was. Was that Frogger or where was that? Do you have like animation? No. Components, game. Oh, you were just main. Okay, we do have animation there. Let's open that up and see. Frogger. Right. Let's get this functionality here. All right. We'll put that in animation. All right, graphics. Well, we could do like renderable actually for that one. Actually, instead of railing, we can update last time. Same thing here. Even though it's probably not necessary, but we should have like game basically everywhere, so it's gonna be fine. Okay, so essentially it's a very simple thing. You have this animation type, which essentially describes an animation with a bunch of frames and how long each frame is, like a baseline. And then we have also animation instances, which like keeps track of any like kind of currently playing animation that has an index. It has animation type, so which one we're dealing with. We have an index, which is the current frame, when we should switch to the next frame, and if it's going to be looping or not. Okay, so that is the idea of this animation here. 1 second. All right, I'm back. Sorry about that. Okay. The thing is, like with Pac-Man, I know that the animation is like it's gonna play while you're moving, I think, and also the sound, because I don't think it's playing all the time. Because so essentially, kind of the animation is kind of tied to your movement, I think. But yeah, whatever. Let's. I'm just gonna make it play all the time. Just to keep things moving here. That's not the super important stuff. That's like polish later maybe. I'll try to implement like the basic gameplay first. But we'll just have like basic animation there and stuff. So what we're gonna do is I probably want to have so what I'm gonna do is I'm gonna make like an animation container. I'll just put this in main, whatever. I just want to move forward here, so we'll make an animation container. This is gonna have all the kind of animation types that we should have. So it's gonna be like pac-man, pac-man. Yeah, just pac-man walk, I guess. Or whatever whatever Pac-Man is using to move around. I'm not sure how Pac-Man moves around. Maybe it's like a bunch of tiny feet that you can't see or something. I don't know. Actually, doesn't like Pac-Man have actual like legs in like pictures and stuff? Anyway, so I guess he's walking around. So let's bring in animation type. Import animation type. Alright, so this is an animation type. And actually let's just put this here, so then we can all actually get this here. So then what I'll do is I'll add this as a singleton. Game animation container. And here we can actually define it. So we have frames and we have frame duration. So frames is gonna be Pac-Man walk frames. You know what, let's say create animation container as a function. Game animation container, whoops. Alright, and then Pac-Man walk frames is gonna be allocating a bunch of frames. Well, the frames are actually gonna be renderables. So let's just see renderables. We're gonna allocate 2. It's just 2 frames, I think. If we look at the thing, it has this and this. I think that those are the only 2 frames. Okay. So and then frame duration we could just set to something. I'm not sure exactly what it is, but whatever. Let's just do like 0.3 or something. I don't know, 0.5. And then we're gonna say 0 is in its sprite. Why are you not? Oh. Catch and reachable. So in its sprite, texture, get singleton, texture 2D. We have our sprite sheet, and the source is something we have to make out here. So the source is just going to be whatever I'm selecting over here. 303 by 709. And then 16 by 16, I'm pretty sure. Yeah. All right, so that's the first frame. And then we have a second frame is at over here. Basically just 303, 692. Yeah, the same, but minus 17 y. Okay, so there we go. There's our stuff there. Now, I'm also quickly gonna add this into dinit. Gonna get our animation container, and we're gonna let's just have a deinitialize function there. Actually, you could do like inline for self, standard meta fields of animation container, or add this, get a field, and this field will be, yeah, we're just gonna call free on at field self field of name. So that will loop through all the fields that we have, which is only a pac-man walk around, and basically generate code. For each field, it would generate this line of code where this field will be. It is essentially gonna regenerate into this code right here, self.pacman walk. What the hell? I just lost connection with. My streaming software here. All right, I think we're still up. Okay. Anyway, yeah. So this will essentially do that. And if you add another one, which is like the death animation, this is automatically gonna generate this code here. So you don't need to specify each one. We can loop through all the fields and do this, and I don't need to do anything else with this deinitializer. So that's good. Actually, these have the initialize functions actually, so we can do at field self field name, and we could just call the initialize here instead. So that we call this function here. Cool. All right. So there we go. So now we have that over here. And there we go. Now we're initializing that container. We don't have pac-man death animation. We can create it. And death frames. Okay, so we can count the death frames. It's gonna be these ones, I think. I'm not sure when this is used, this ball sprite. I don't know if that's part of this, but this is the death animation. It has like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 frames. So 11. And then we just implement those. So that's gonna start out at 201,692. Now, since all of them are basically on like this grid here, what you can do is I'm gonna, and the spacing is like 17 here. So I can actually just create a cursor that initializes to, well, actually, let's make this the rectangle. We initialize it to the starting point. And so this will be the cursor. So we always put in the cursor here. So essentially, we'll just do this. 6, 7, 8, 10. That should be all of them. And now we just need to modify the cursor. So we basically would say cursor x plus equal to 17. That's the spacing. Spacing is 17. Or technically, I mean, spacing usually means the space in between the cells, but whatever. I'm just gonna do this. So then we basically just need to do this, except when we get to one of the row ends, whoops. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So when we go from, well, this is 0, 0, 1, 2, 3, 4, 5. So after 5, index 5, we need to reset x back to the start, which is going to be 201. But we're going to add cursor y. We're going to add spacing to cursor y instead. And then after that, we can continue with x. Okay, so there we go. Now we should have that animation, the frames there. And we can also add this over here. That frames. I'm not sure what the duration of the frames are, probably a little bit faster. Let's just do this. The full yellow circle frame is the last frame of the walk animation. Really? Oh, I didn't know that. So the walk animation, oh yeah, okay. The walk animation has three frames then. Interesting, thank you for that information. All right, let's fix that. So this one is at 33726. I mean, I guess it goes from this to this to this, and not like this to this to this. So we should also change the order here. I'm gonna move you like that. So that should be the walking animation there. Okay. What the hell? How did this happen? Okay, well, anyway. There we go. Okay, so we have the death animation, the walk animation, like defined here. Now we can also, okay, so what I'm going to do actually is I'm going to add a component, animation component, and I'm actually going to copy or bring over this thing over here because I don't need to explain myself to you. No, I'm just kidding. But yeah, so yeah, that's it. You don't really need game. Well, you do need game. You need allocator. Okay, sure. Cool. Okay, so now we have that as a component. I need to add it over here. Animation. Sort. Okay, so now we can add an animation component to our player, and we need game, we need animation type, which exists in our animation container. So I'm actually gonna make a convenience function here to get our animations. Animation container. All right, so let's get our animations. Actually, I'm gonna make a function here, create player. Put this in there. Okay. So we'll just do that. This could be placed in like create like init singletons or something, but whatever. Create the players. Player, sorry. It's not a multiplayer game, but that would be kind of cool, I guess. Actually, is there like a multiplayer Pac-Man? Look at the video of the actual game, you'll notice the same. Yeah. I mean, I might do that at some point. I'm just gonna go by memory for now, and we'll see. I'm not trying to make a pixel perfect copy of the game. I'm just trying to make like the basic core functionality work, and then maybe we'll get to some of the intricacies of the game if we have time. Right, we need the sprite sheet is texture 2D. We need animations. So this thing needs animations dot pac-man. So we start out at pac-man walk. Like you can change out the actual animation, but we'll start out with walk. Looping is true. All right. Okay, I'm just gonna run this to see if everything compiles and works and stuff. Still. Okay. Cool. Now I want to implement checking for animations. So when we draw renderables, I want to actually, I mean, either we could just do it here, or I can make like an animation system that actually like takes care of this. Let's do that actually. Animation system, and we need game. We need an update function. So we need an iterator that goes through everything that has renderables and animations. Because then we don't actually need to worry about the drawing function, because that already should be taken care of. So here we do like next, we get a context. Okay, we'll get our animation. It's gonna be get animation, and we get our renderable. Well, let's do that after. So we'll do like update, and after we've done update, we're gonna get the renderable. Well, you can just put it here, whatever. Renderable dot. Actually, we could just overwrite this renderable, and we could just call get graphics. That will like just set this to whatever it needs to be from the animation that we have. Okay, and that's basically it. Then I need to add some stupid stuff here just because that's how it works with this thing. Alright, and then in systems, we also need animation system here. Okay, and then setup, we're gonna need to add the animation system. There we go. And in update, we also need to, this could happen like anywhere. I'm just gonna put it up here probably. Yeah, animation system. All right, cool. So that should now work, I think. We should see the walk animation now. Yeah, cool. It's a little bit, okay. It's a little bit badly animated because I did not choose the correct frames. So this frame, it should go back to 1, like here. So we should have like 3. It should go back. We can just copy over 1 there. So it goes, yeah, if we look at the sprite sheet, it goes from this to this to this, but then it should go back to this and then back to this and then, you know, like this. All right. I'm just guessing that's how the original should be, but makes sense to me. There we go. Okay, yeah, now it makes sense. It makes a lot of sense. Okay. We could change, maybe this is a little bit faster. Probably. Also, the death animation is probably even faster as well. Yeah. Let's make it even faster. Okay, 1 second. All right, sorry so much about the abortions. Interruptions, that's what it's called. Okay, so let's see. This should probably be faster. I'm not sure. Let's try and show the death animation. We can just switch this out to death here. And that shows us the death animation. Okay, cool. That looks good. All right, cool. So now I want to make it so that Pac-Man actually faces the direction that we're looking, and that's pretty easy because we can just rotate Pac-Man in that direction. So essentially what we could do is we could have on, we could probably add let's just we don't really have a good place to put this unless we make like a system or whatever for it. Maybe if we put animation after physics, because then animation could take care of that actually. It should also only happen for Pac-Man really, because the ghosts don't rotate, they just float around as they are. So okay, you know what? Let's actually do this. Let's just make a Pac-Man system specific for Pac-Man. Game. And no. And actually, the thing is, like with Pac-Man, we don't really have. Let's just make. We don't have a component that kind of marks Pac-Man, so I'm gonna make a Pac-Man component. Yeah. Okay, so here we go. Here's the Pac-Man components. Pac-Man. Systems. Okay, and then we should probably have like ghost components, stuff like that as well. And when we create the player, we also add the Pac-Man component. So now we can like get Pac-Man. I'm also gonna add a convenience function to get Pac-Man here. This will give us entity context. So essentially, I'm gonna add a convenience function to get one entity. No, I'm not gonna do that actually. Well, I might. Well, it's kind of like, because we're gonna create basically I'm gonna create an iterator, entity iterator, which includes Pac-Man, and then we're just gonna return next, unwrap that, because that's gonna give us the Pac-Man entity, and then we're done there. I feel like you figured out the right animation duration based on the sound effects it makes. Yeah, probably. Yeah, the sound, we could probably just... Yeah, we should be able to just download the sound at some point. But let's see, so now we can grab Pac-Man, we can go to the Pac-Man system, and we can get Pac-Man here. That's just gonna be game.pacman. Alright, so now we can say... because this should happen like after. Oh yeah, this is called update. This should happen after physics. So essentially, we should have like the velocity is gonna determine. Velocity is probably always gonna be. 1 second. All right, sorry about that. Pac-man is basically velocity is gonna determine then the direction. But if the velocity is 0, we're just gonna keep the last known velocity. So, because then we don't really have a direction there, I guess. So, velocity. So basically, to get the direction, it's gonna be, or radians here, it's gonna be a10(2) of the velocity. So velocity y and velocity x. That is the degrees in pi coordinates. Okay. And then we'll basically divide r by, I guess we'll divide, let's see, or we could divide by 2 pi and then times how many directions we want. So basically we want 4 different directions, I think. Yeah. So we divide by 2 pi, add, and then times 4. That should give us the 4 different, and then round, essentially. So we divide by pi times 2. Because now the radians is converted to 0 means the right angle, and 1 also means the right angle, but it's a full revolution or whatever it's called. And then we wanna take this and times by 4, because that's the number of directions we're interested in dividing the circle in. And we're gonna say, we need standard here. We're gonna say then, and then we're gonna round that. We could also make it into an integer by this point, but sure, let's make it int from float. So we're essentially taking the rotation of the velocity. So we're getting the direction. 0 means to the right. So we could switch on R. 0 means to the right. Actually, you know what? We don't need to do this. We don't need to do this here. We can just... Actually... No, this is stupid here. I already have rotation. We could just set body rotation is equal to that. Except it's not. Okay, but we do want to round it off to 4 different things. We probably, but then we want to convert it back to degrees again. So we want to divide by 4 to get back. We basically want to like do this again here. What operation is this here? Can we merge this? A10(2) this times that, and then 4 times that. So this division, so the first one is 1 over math pi times 2. And then we times by 4. So essentially it's going to be 4 over, right? And that's what we should... And then this is the... origin. I'm just gonna call UR. And then body rotation is gonna be R times D rounded and then divided by D back again. That should give us the rotation we want, I think. Because we get the rotation of the velocity. Velocity, both of velocity could be 0 though. So because now, if we run this, it should, like, when you release the directional joystick, it's gonna go back to looking at the right, because this would be 0, and then this would be 0 as well. I need to add the pac-man system. Pac-man system. I need to call this after physics. Okay. There's an issue somewhere. Not constant. So we should get some kind of rotation now, I think. Or not. Are we actually rotating now by the thing, though? No, actually, it's not the body rotation. It's the renderable rotation. We should get the renderable. But we don't have, well, no, wait. It is the body. When we draw the renderable, we take the body rotation into account. Yes. And we are calling this DR. I'm just gonna check what these are gonna be, and then the rotation. Okay, so body rotation. So it should be rotating. You can see this 0.78, that is like, I don't know. Yeah, but it does look like it should be rotating. But it isn't. Oh, you know what? It could be because the animation system is overriding, perhaps. Maybe not. No, it's not, because we... So this happens here. Body rotation is changed. And then we draw. Because this is drawn, this is happening after. Oops. And body rotation is taken into account. What the hell? Wait, are we actually taking it into account? Draw rotation. Rotation. Yes. You know what? We are taking it into account, but it's some functions in raylib needs conversions from radians to degrees. Okay. Whoa, what the hell? Okay, cool. So we are rotating, but we're rotating around at different points. God damn it. So the origin, okay. So origin is gonna be destination width over 2. But then we also need to change the destination X. This is gonna be, I think, negative. Okay. Let's see if this works. Yeah, so we're changing like what is the point of rotation. Now it's the center. However, we see that we also draw Pac-Man in the wrong spot. So let's try adding the origin here. There we go. However, you can see, I mean, you can argue if this is this good or bad. You can, because Pac-Man is going the way I'm kind of, you know, moving my joystick here. Okay, but you know what? I'm gonna leave it like that. Actually, I'm not gonna worry about that too much. I'm just gonna keep going here to make some progress on the actual gameplay. That's good enough. We're rotating, but the problem is also, okay, one thing that I want to change though is whenever I release, it goes back to the pointer to the right. I want to keep the same thing. So what I'm gonna do is I'm gonna check if velocity x equal to 0 and velocity y equal to 0, then we don't do anything here. So that will mean that when we release the stick, we won't like try to calculate the rotation again based on velocity, because we don't basically have a velocity. So now we should keep our rotation whenever I release the stick here. Cool. Great. All right. I'm not sure what went wrong here, but it had kind of a funny effect, so I'm gonna leave it like that. Okay, so we have our Pac-Man going around. We have our wraparound. We have a collision detection in the maze and stuff. Now the next thing is, well, we could do like the pellets. We could do ghosts. I guess we can add the pellets now. So I think let's go to our maze. So you can see here that the maze is defined in the string format here, and spaces that have space are empty. These define like different kinds of walls types. And then we have like the dots. The dots are kind of, they're also empty now, but we can actually put like where there are dots, there should be pellets perhaps, right? So I'm not sure if the original had pellets everywhere, but we can modify that later. I'm just gonna do make the thing work here. So let's say that space is gonna be space is empty, and this is a tile with a pallet. So we have a pallet, and you are also empty. but you're gonna have a pellet. I'm gonna see has pellet. Okay. Now I'm probably better to put this like in an options thing instead, perhaps, than to add one thing more here, but whatever. Let's do that actually. Let's do like options. It's gonna be, actually it's a struct. So is solid is a bool, has pellet is a bool. I'm gonna add default values as well, or I'm gonna add, you know, a wall is an options that have is solid true, has pellet false. Angle code will be equal to, yeah, I know I know Sammy Hacker, but I thought it was a fun effect there, so I'm just gonna keep it like that for now. Like that was what I was trying to do, but it ended up being a bug there. But I think I'm just gonna keep it like that, because that's, yeah, it's just yeah. Okay, well, let's do it like this. So we have wall, empty, and palette. Okay, and then instead of doing this, we're gonna put in options. Okay, and then is solid is going to, well, we could either do that, or we could just put options in here. That will make it a bit easier to copy over as well. We'll just say options equal to options. Okay, and now it's going to be easier to define, because, oops, over here we're gonna say true is gonna be a wall, and that is essentially gonna be all of these. There we go, those are walls, and then you are a pallet and you are empty. There we go. A little trick there in Zig, which is kind of cool. Okay, but now you don't have is solid, you have to go options is solid. We can also make like a convenience function, I guess, for it as well. We can make like, you know, is solid and return options is solid, has pellet, we can also do like, no, that's fine. Okay, so now instead of doing this, we can do is solid. All right, there we go. Let's see if it still works here. Yep, still works. Okay, cool. Now, what do we want to do now? So we probably, yeah, we want to add like the palettes. It could be part of the grid data, the palettes. So yeah, we could actually have like has palettes as a thing in the bool, because that will do two things. It will actually, we have the data if we have a pallet here or not, and also when collision detection happens, we can check like, okay, well, there is a pallet on this cell, and does pac-man collide with the pallet to eat it, you know? And then we return an event that says that, hey, we have eaten this pallet here. I guess the only thing that is kind of bad with this is like we don't have an easy way to keep track of all the pellets. But what we could do, like, because when all pellets have been eaten, that's when you win the game, right? Or win the level. So that will be like the end game of this game that I'm making here. I'm not gonna make like all levels or anything like that. I'm just gonna make one level, the first level or whatever, or my level. Doesn't necessarily be exactly as the original level. So when you've eaten all the pellets, you win. But basically, to keep track of the pellets, I'm thinking I'm just gonna calculate how many pellets are in the maze by just summing up all the pellet cells, and then just have an integer that keeps track of how many pellets are left. And whenever an event says that, hey, we've eaten a pellet, we're gonna decrease that by 1, and when that reaches 0, you win, essentially. So that's how we can do it here. I'm gonna say that this is 0 for now, and we should get some error somewhere. No? Oh, because it's default, right? Well, okay. So let's see. Where did we generate the grid? All right, we generated, I think it's set up here. So is solid. And we also have has pellet. Okay. So there we go. Now the grid should be populated with that information. And I'm gonna draw the pellets now. So we are going to draw the pellets. I'm gonna make a, well, when we draw the maze, we should also get the information of the grid. So get singleton. Well, wait. No, that's the physics, right? Yeah. The physics system has the grid. So this is the physics system, and then we have the grid, is physics.grid. There we go. Okay. And then we're gonna say the sprite and then here we're gonna get this grid cell. It's gonna be grid. I'm gonna make like a get cell function here somewhere. Get cell, and we have x and y gives us a cell. So we return, also we need self. Actually, it doesn't need to be a pointer for this one. Okay, data x plus y times self.width. Okay. So we get the cell of, oops, x and y. Whoops, but these are, oh, wait, we already have the index actually. So, okay, so we already have a cell. This is the grid cell. So we could just do this to get the cell, okay? And then we'll say if the cell has a pellet, we'll draw the pellet. So I'm gonna make, we're gonna have to make a pellet renderable. It's gonna be a sprite. The texture is texture. The source rectangle. We can look up here. Where's the pellets? The pellets. Anybody see any pellets? Is it those ones. Hang on, let me look at a screenshot here because I am a little bit confused. So the pellets are like just small dots, and then you got the large pellets, which are the other ones. I'm just gonna pick this color up here, perhaps. So that's the pellet. Here's the normal pellet. I'm not sure what this is, but this is the normal pellet. It's 13610 8x8. 13610 13610 13610 8x8. That's the pellet. And if we have a pellet, we will draw that pellet. Pellet renderable, draw. Position is, I mean, it's just going to be in the center, or I mean, at the thing here. So it's just going to be X and Y here. Or actually, it's just position. Yeah. Rotation is 0. Okay. So there we go. So now we should render all the pellets there. Hopefully. Yeah, there we go. We have a bunch of pellets. Okay. And then there's like the large pellets as well. Let's just put them in there. So we have the large pellets. I guess we have like a normal pellet, or we also have the large pellet. So I'm gonna make this like a pellet type. Pellet type is an enum. It has either small or large, and or none, I guess. UR.none, UR.none, UR small, and we'll say your small pellet and then a large pellet. Okay. And then has pellet, instead of doing this, is gonna be, well, actually it's probably better if it's an optional, actually, instead of none, because then we can use like an if for that. So that's gonna be a null. Okay. Because then here we can return a pellet like this. And instead of calling it has pellet, we can just call it pellet. Okay. And then you are actually also gonna be called pellet. And you're gonna be pellet. And this will be like maze.pellet. Wait. Oh. Sell the pellet. Okay. And now, instead of getting just a bool here, we actually get a pellet type. So we can switch on that type. And we can see if we have a small pellet, we will draw this one. And if we have a large pellet, we'll draw another one. So this is the small pellet renderable. And then we'll have a large pellet as well. And you are located at 2 doors down, 13628. So 28. Yo, 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 cool guy. What's up? What's up? How's it going? All right. So there we go. Now we need a way to put them into the maze as well. Here's tile pellet. Let's change you actually to small pellet. And you're the large pellet. Right. It's gonna be 1-1 because that's like an empty. Well, you know what? We could have made it part of. No, whatever. No. It's dynamic data. This is the static one. Yeah. So what will that be? We have the small palette is a dot. We already have star and O. What would the large palette be? We could do. We have plus already. We could do this weird one, maybe large palette. Okay, that does not mess with my software. I'm not sure where those are. I'm gonna look at a screenshot. So it's gonna be 2 doors down here. You are a large palette. You're a large palette. And then it's gonna be at the corner down here, I think. Okay. That's just what I see from a screenshot there. First time seeing part 2 of the same game. Yeah, I thought I wanted to continue with Pac-Man because we didn't get very far last time. Oh, we got an issue here. Okay, of course we do. Of course we do. So I'm gonna replace you with, I don't know, maybe ampersand. Why did that not work? Why isn't it working? Is it because that's like a weird... Yeah, I can't even search for it. The reason why I have to remove like the ones in between, like after and before, is because sometimes if it was like a weird UTF-8 thing, like a Unicode or something, then sometimes you get like things in the other directions there as well. Okay, there we go. Cool. We got our little pellets in there. Now let's see if we can make it so that we can actually see if we collide with a pellet or not. I'm just gonna make like a very naive version first, where every grid cell you collide with that has a pellet in it is gonna be it's gonna have that thing there. Hello, Pack the Rap. Okay, nice. Nice, Pack Rap, having it as ASMR. That's cool. Secondly, regarding degrees to usable values, look into arctan mod arithmetic when you find a minute. Oh yeah, sure. Thank you. I mean, yeah, I was using arctan 2 to get the direction. The problem is that I wanted to divide the circle in 4 directions, like up, down, left, right, and then round the direction to one of those, so it's basically snaps to those directions. And I thought I had a method for that working, but it does snap, it seems, to some type of degrees, but it doesn't snap to those 4 directions. But the effect was kind of funny, so I'm gonna keep it in. Basically, on a 2D map with 4 directions, you have 4 split sectors, multiply 4 to stay int. Each arctan 2 is full rotation. You can convert degree to floor integer returns. Okay. Oh yeah, thank you. All right. Yeah, I'm just gonna keep it as it is right now, and maybe we'll come back to that later. I just want to get the core parts of the gameplay in, so we can actually play the game, and then make, because that's like, you can still move around. That's just like animation, so you can still like move around and do that. So I'm just gonna leave that for now and think of that as like polish to fix later, or just keep it as it is right now. So okay, so let's see. We've got, now I'm thinking about this, the palette stuff, because what we could do is we could say, because right now we're aborting here for collisions, for adjusting the body. So what we could do is we could say, we could still abort the collision check and resolving collision, but we still want to check for collision against the pellets that we're colliding with. So what I'm gonna do is so we still want to go through all the candidates and check if we collide with any of the pellets inside. So what I'm gonna do is I'm gonna have a flag that says like, have we resolved collision? Has resolved collision, or is collision resolved? Is false to start with, and then I'm gonna add a check here to say, well, okay, we actually don't want to skip if it's not solid anymore. Actually, this is only for checking for a collision now, but then we still want to go through each one to check for cells that have pellets in them as well. So I'm trying to do that at the same time. We could also make 2 loops, like going through each one 2 times. Like, that's not that big of a deal, actually. You know what? Let's just do that, actually. So, but then we don't want to return down here. Or what we do is we check for pellets first, perhaps. Okay, sure. Let's do that, because you're never going to have enough speed to be able to phase through a wall anyway. So we can go through here. So this one will be check for pellet collisions, and this is the actual collision, so wall collision resolve. Okay, now we want to get the pellet hitbox somehow. I'm gonna set this to undefined for now. We're gonna figure it out. So we have the pellet hitbox. We're gonna check if my hitbox collides with pellet hitbox. I saw this earlier. Like, you don't have to call like raylib check rex collisions. You can do that. The rectangle themselves also has the check collision function, which just calls check collisions against the other one. I guess this is a convenience thing that the wrapper library here added here. I'm not sure, but yeah, that seems to be a good thing. So we can just do that. Okay, check collision against the other one. So if we have a collision against the pellet, what we're gonna do is we are going to say, I'm gonna say here, pellets collided is gonna be 0. Let's make it a U size. You have to assign a type if you're gonna modify it. We're gonna add pellets collided plus equals 1, and then we're also gonna say that the cell, so get cell, no, just get cell x and y and we're gonna say the palette is, actually we probably have this down here, and this should be like actually a pointer. So actually I'm just gonna do this, x plus y times. Okay, so cell.palette is gonna be null because we ate it. Okay. And then we're just saying that, okay, we keep track of how many we collided with. We're gonna eat all the cells that we collide with. And then we need to figure out the hitbox. But yeah. So then at the end, if we return like a collision event, we also need to make a function here like toCollisionEvent. Pellets collided is usize. And this gives us a collision event. Okay. And then it's like if pellets collided is more than 0, we're gonna return pellets. Or we can actually say that you could probably collide with both at the same time, maybe, I don't know. We can make it a struct, actually. Let's just make it a struct and we'll figure it out later. So pellets, we don't get an entity actually. So actually we get like a usize, because yeah, the ghost though, we might get an entity for the ghost, or it's an, actually, do we care which ghost hit us? I'm not sure. Let's just do a bool there. Or let's just do that, whatever. Okay, so pellets. Let's call this pellets, actually. Pellets is gonna be pellets collided. And ghost is gonna be null for now. Okay, so that is our collision event. We are going to say that this is 0 here, and because we didn't actually, wait, why are we returning actually? Because there's only one pac-man really. That's the thing, there's only one pac-man. However, we do want to let's do this. Let's do like optional. This returns a null. Yeah, we do want the ghosts to be colliding as well. So we don't want. So we do want to solve for the things, but okay. Let's. I guess we can keep an event going here, and at the end we return the event. We don't want to return here, because then we don't collide with, then the ghosts won't have their turn to collide. So I guess what we'll do is we'll check if I'm gonna implement a thing called has, which returns a bool. Okay. So essentially, if we have pac-man, then we're gonna return a collision event. Then event is gonna be pellets collided. And essentially, we only need to do pellets if we are pac-man. Otherwise, we don't need to do the pellets. Okay, there we go. Okay. So the only thing I guess now left here is like if we have like we should get the pellet hitbox. We also need to check if we actually have a pellet here at all. So I'm gonna say the pellet. If we don't have a pellet, then so or else we just continue to the next cell. And the pellet hitbox, I'm actually gonna add like a hitbox function there. Let's make a hitbox function here. This gives us a rectangle depending on, I'm not sure if this is actually how it works, like if the large one has like a larger hitbox than the smaller one, I'm not sure. But I'm just gonna say that they should have like, the small one has like a 2x2 and the large one has like a 4x4 or something like that. Let's just say that's the case. So we're just gonna switch on self, and if we're small, we're gonna return a so 8x8 is the entire thing. So the center or the top left will be like 3x3, I think. Yes, or is it 4x? No, it's 4. 0, 1, 2, 3, 4, 5, 6, 7. No, I think it's 3. Okay, and then large is gonna be start at 2 and be 4x4, I think. Or am I crazy? This is gonna be like 2, 6, and then 2 at the end. 3, 2, and then 3. Yeah, that's, I think that's centered. It felt weird, but yeah, because the X and Y are like doubled. So yeah, okay. Cool, and then pellet hitbox. Now we need the offset. So the offset is going to be cell. So that's going to be like X times. I have to make fx is f32 float from int x fy. So float of x times the cell size. Okay, that's the offset. Isometric quasi 3D real-time strategy games, Diablo. Yeah. That is a cool project. Maybe in the future sometime. We'll see. That would be really cool to do, but I have a ways to go, I think. It's gonna be a longer project for sure if I'm gonna go there. Okay, so we got pellet X, pellet Y, let's see. So there's our hitbox there. So we have the hitbox is the size is correct, the X and Y needs to be offsetted, which we're doing here. And then we're checking a collision against our hitbox. And then we should be colliding with that one. Okay. Now I'm pretty sure we should have a compiler because we are checking for this collision here, I think. Or no, we actually discard it, actually. So never mind. Oh, whoa. What's happening here? Hang on. All right. So we have to, right. So here we actually do want to break. I'm going to call it the outer or resolve loop. So actually I'm gonna break resolve loop. We're gonna break out. Now we're keeping the same functionality as we had before. It's just that we allow more, like all entities, to be able to collide as well. Okay, there we go. So there we go. Now we can eat the pellets. And what we need to do to check, like, if we've eaten all the pellets, is just we can even eat the large ones. Okay. It's just gonna be like we're gonna calculate how many pellets are. Yeah, let's just do that. So we're gonna calculate how many pellets do we have from the start. So let's actually, I'm just gonna add into game here. Pellets left. I'm just gonna initialize to 0. So during setup, when we create the grid, we're also gonna say how many pellets do we have. Actually, this is an interesting question. Do large pellets count towards completing the level? Like, do you have to collect the large pellets to complete the level, or are the small pellets enough? Hello, Polaris. Have a nice day yourself. Thank you. How's it going? Pellets. So I'm gonna call this n pellets. Start at 0. We are going to say if we have a pellet you exist, right? Yeah. So what's your issue? Oh, typo is the issue. So if this is not equal to null, number of pellets increase. Okay, and then at the end we're gonna set pellets left. It's gonna be number of pellets. Okay, and now we're gonna say we're gonna go to game. We're gonna make a main state of the game. It's gonna be starting at playing. I'm gonna make this stage just gonna be an enum. So either we are playing or we have a win. Okay, and then we're gonna say update. We're gonna check at the end here if pellets left is equal to 0. We're gonna change our state to be win, and then so now essentially we can say if we win, then we can draw win text. If state is not equal to win, we don't do anything. If we have equal to win, we can draw text. Congratulations. Congratulations. Did I have centered here or no? No, I don't. Are you centered? No, you're not. I'm gonna make a centered version here. Position is screen size. Actually, it should be pixel size because the zoom is still applied. Pixel size, scale, half. So it's going to be at the center. Congratulations. Make this cursor here. Cursor y plus equals to, I don't know, how big was this text here? 8? Let's add like 16 or something. You won the game. Alright, we need this centered text drawing function. So I'm just gonna copy you, centered, and we're gonna have width is measure text, font size. I'm gonna make a thing here called font size. So we'll have the same one. Then actually we could put it over here actually. Yeah. And then the position, so X will be position X minus width over 2. So that is X. And then Y is just position Y. Now actually Y is position Y minus font size over 2. Should just be you win. Okay. All right. As I said, doesn't have to be pixel perfect. Thank you for the input. Probably, yeah, I could change it. I mean, the font is not gonna match. The font size is not gonna match. It's just gonna be a message telling you that you win. This should actually, it doesn't work now because we don't do anything with the event, the physics event. So we're gonna get the X event, and here's the Y event. Let's have like, I don't know, process event. Process collision event. All right. Sure, let's add it down here. Process collision event. We need game, of course, as well. And the event is going to be physics. No, it's going to be grid collision event, but it's optional. And so we'll call this maybe event. And we'll get this event, or else we don't do anything. All right, so then we can say game pellets left minus equal to event pellets, and that's basically all we need to do there. And of course we can pass in game here as well. All right. This reminds me when you win in the King of Fighters 97. Oh, really? I never played that. Okay, let's see if this works. Waka 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 waka. She gets some sound effects in as well. It's pretty. Alright. Sometimes it's kind of hard to turn the corners. Yeah, but I'm actually that feels like polish. Like you can turn the corners pretty well. It's just that sometimes it feels like you get stuck. Okay, well, nothing's happening. What the hell? Let's do like this. Let's draw. How many pellets are left? Wait. I never called draw win. Oh. Draw win. Okay. I'm gonna do this. I'm gonna make a copy of this maze. I'm gonna make another level, a debug level. Okay, this is the debug layout. And we're basically, I'm gonna replace all dots with spaces. Yeah, that should be it, because then we only need to gather the large dots. And I'm gonna say like selected level is debug. All right. So now we should only have. Oh, what's happening? Oh, now we're calling this. Okay, yeah, sure. Does that fix your issue? No. Well, let's do F32 float from int. Okay. Okay, now we just need to collect these large ones. Should go a bit faster. I could also just made it a little bit easier, but whatever. No, okay, nothing is showing up. Cool. Huh. We call this function. The state should be set to win. Okay, another thing that I want to draw is I'm gonna draw like the HUD. So we're gonna draw a HUD function, and I'm gonna copy you because I want to show how many pallets are left basically. Center is that. What we could do is we could initialize, we copy center, but then we set y equals just font size over 2 plus some padding, and then we'll say pallets left game pallets left. There we go. So we should see at top how many pallets are left and if they decrease when we collect the pallets. Okay, pallets left is 4. Okay, they are not actually decreased. Okay. So either this doesn't work, we get an event, we process it, and we do that, or the event that we get back from here does not actually work. We return this event, we set. Oh, I see. So even if we don't, okay, so we have the case when you collide with a wall, we set the event, right? But if we don't collide with a wall, we should also set the event. So I'm gonna make an else here. We could do it in another way as well, but I'm gonna make an else. You can have an else on a for. If the for loop gets exhausted without breaking, or yeah, it gets exhausted basically. If you don't break and it gets exhausted, you get into the else branch. Okay, so there we go. We should set that there as well. So that should fix this issue, I think. Hopefully. Yes, there we go. All right, let's fix this now here. Yay! Okay, cool. So we have the win screen basically. The game still keeps playing, but whatever. What is this YouTube video you pasted here? Is that the King of Fighters or something? Yeah, congratulations, happy birthday.
Congratulations!
Congratulations! Okay, I shouldn't make fun of that. Anyway, I was just trying to mimic that as much as I could. Okay, anyway, so let's see. Thank you for that. Let's continue here. When you finish the game, Japanese announcer says, "Oh, okay, I see." That's cool. It also, you know, you have the, what is that? I think it's Sega Rally or something like that. When you get game over, it's like game over, yeah. That one is actually the funniest like game over sound I've ever heard. Okay, so cool. We can eat the palace. We can win. So now the only thing left, I guess, is the ghosts. And I guess, yeah, the large pellets also gonna have like the power up and stuff, but that doesn't really, and I guess the score as well. What did I do? I'm not sure if I did anything. Okay, cool. So the ghosts are probably the most intricate parts of this puzzle here. So yeah, there's 4 ghosts. They each have their own way of doing things, which I've never really learned as a player of the game. We have, I mean, we have all these different palettes here. I'm not sure which ones are the correct ones. I know that these dark ones are when they, and possibly this and this are like when they flash when you have the power up. What the hell is this though? I've never seen this. Oh, is this when they like go back to the prison or something? What's happening here? And then we got all these like point things. I think this just gives you points or something. Time for me to implement the actual AI. Yes. So I'm not sure which ones are like the original palettes here. Maybe I'll do a special kind of renderable for the ghosts, because there's so many different ones, but they are all aligned here in a good like layout here. So also there's like the black one, which is basically invisible, I guess. Well, maybe not invisible. Actually, I shouldn't have deleted the black one. However, there was no distinction between the outline. Well, maybe it is transparent. I don't know. Wait, why are these eyes gone? Were they black? That doesn't make sense. Because I selected everything that was black and deleted it. That's why this is like a transparent background. Why are these like transparent here? That's weird. Maybe they're blinking. Okay, but anyway, I think what I'm gonna do is I'm gonna implement some kind of struct that will be able to like select the correct version of the ghost. Also, I'm not sure what these are for. But they will select the correct version of the ghost, depending on, and also like, so you'll be able to select the ghost kind of frame, but then also it's gonna also select the correct palette as well. So I think what I'm gonna do is I'm gonna add these as maybe like an animation. Well, the animations are gonna be like these parts, I think. Yeah, it's gonna be like walking. You know what? You know what I'll do? I'll just add these two as an animation. And then depending on the direction, it's gonna shift the source over to the correct thing. Okay. And the palette also switch like over to the correct one. So I just need one animation, which is this one. I'm gonna implement the walking animation here. So it's gonna be starting here is 183. So let's go to setup and we have our animation here. So we're gonna need a ghost walk. That's gonna be allocator alloc. Renderable 2. Hello, Pack-a-Rap. Lost connection. Thunderstorm started. Oh man. Will this get a part 3? I don't know. It depends on how much time I have and how much I get to through this day. I will probably not be able to complete all the ghost stuff here. I'm gonna try and implement just getting them in the game and then see how far we'll get. But probably not the power-up though. And possibly not like correct AI or something. We'll see. So we have the ghost walk animation. I'm gonna catch and reachable. Ghost walk. Actually, this is frames. 0 is gonna be in its sprite texture. And this one, I guess we can continue using the cursor actually. But now the cursor X is gonna be whatever we had here. So it's gonna be 183. So 183. Because the size should be the same. Size should be 16 by 16. Okay. And then we'll add one, we'll just move X over by spacing. Okay. So that's the ghost walk animation. Ghost walk. Okay. Cool. Now, let's just let's make a function, create ghost. Also the ghosts, I mean the ghosts are weird. Like they can phase through the middle of the prison wall and stuff like that as well at some points. But we'll figure it out. So we need a sprite. Do we need a sprite sheet? Yeah, probably. Actually, we don't. I don't think. We need animations, and then we're gonna get a ghost here. We need like a ghost variant, but I'm gonna make that later. Let's add the animation. That's gonna be the ghost walk. It's looping. And then I'll grab out the animation again. And I'm gonna just add the graphics in there. So that will get us automatically the correct like renderable. We can also do that up here, but whatever. And then we'll also add the body. Starting out at, I don't know, 128 or something. Is that like in the middle? Not sure. And it's not controllable. It could have a hit. Actually, we do need to put the hitbox in there because otherwise it's gonna have the same problem as Pac-Man. Animation, Pac-Man. So yeah, that's it for now. We'll create a ghost. Okay, and let's see how it looks. we got some issues. Player, yeah, sorry about that. Why is it taking so long? Okay, there we go. There's a little ghost. Cool. I guess we'll set the layer, we'll set the maze back to the normal one. Okay. You can look at this while I go and grab myself a cup of coffee. All right. Yeah, so what the idea that I have is that essentially I'm gonna make like a ghost component. Ghost. Okay. And the ghost is gonna have, first we're gonna have like, what is the what is it called? Palette. Okay. So the palette is gonna be something. And then it's also gonna have direction. But the direction we already kind of know from, that's gonna be like the body rotation actually. But yeah, we're gonna have a palette. The palette is just an enum. And what kind of ghost do we have? Let's see if I can remember. We have definitely a red one. Wait, do we have a red one? Actually, I don't know. I actually don't know the colors of the ghosts. I'm gonna have to look at. Okay, we do have a red one. Yes, red. Maybe there's different depending on the level. And then we seem to have like a turquoise or cyan or whatever this color is. Cyan, I'm gonna call this. Actually, they do probably have names. I know they have names. I don't know the names. I'm gonna, you know, call them whatever color they have. So these are the colors we have, the palettes here. Okay. And what we're gonna do is I'm gonna map these colors to their corresponding like offset in the sprite sheet. Okay. But we'll do that in a minute. Blinky, Pinky, Inky, and Clyde. Okay, thank you, Sammy Hacker. I'm not sure what colors do they correspond to then. Is Pinky pink? Is Inky red? Collectively known as the Ghost Gang. Okay. Oh my god, we're getting the lore, the Pac-Man lore here. I didn't know they were called the Ghost Gang. That's insane. Okay, cool. The Ghosts of Pac-Man. Okay, there's even... I mean, I'm not surprised that there are like a little bit of lore. It's... Who are like... Okay, from left to right. So Blink is red. Clyde is orange. Inky is cyan. And Pink is pink. Okay. Do I want to call them by that? Or... Sure, let's do that. So red is Blinky. Clyde is not cyan, but and then inky and pinky. Pinky is of course pink. Inky is cyan. Clyde is orange and Blinky is red. Thank you. Okay. Now I want to find all the different versions of there. So basically, this will be 0, 0. Like Blinky here. I think this is one. Blinky here. Yeah. Blinky is 0, 0 because yeah, that's the first one. So I'm gonna make a function here called offset, and we're gonna get a vector self is a palette, return switch self. Okay, so Blinky is gonna be 0, 0. All right, and then what do we have? We have Pinky. I mean, this is kind of pink. This is also kind of pink, or I don't know. This also looks kind of pink. Like, I'm not sure about these palettes here. I'm gonna assume it's this one here. So that's 1 over. So if you take the position of this one, which is 201, so it's basically 200 pixels over. That's a nice even number. So it's gonna be 200 pixels over there. Whoops, that's Blinky. Pinky is 200 over. Okay. And then Clyde is orange. But this one is cyan, I guess. There's no other cyan here. Which I'm gonna say is like 401. Yeah, so 200 over again. So Clyde is actually 200 over there. And Pinky is orange. Is this looks kind of orange? I'm gonna guess it's this because this are the 4 main. It feels like these are the 4 main things. I'm not sure when the other ones are gonna be used, or if it's just like the different palettes that exist in the game, and then it's used for different, like maybe it's not even used for the ghosts. Yeah, so I'm just gonna move that over. So 600. So there we go. There's our offset for the different palettes. No, you're gonna say pack wrap. You're gonna see. Okay, so that's it there. That's the palette, and then then we also have like the direction as well. So the thing is here, I'm gonna make a convenience function here to it doesn't actually have to be on ghost. Actually, no, I'm gonna have a ghost system that does this actually. Systems ghost. Ghost is a struct. We're gonna get game in here. Gonna have label in it. We're gonna have update. And we're gonna have game storage. We're gonna iterate through all the ghosts, but we don't have the ghost yet in components, but we need to add the ghosts. And sort. We also need systems. All right. So there we go. Now we should have ghosts there. All right, and then we iterate through the ghosts. Okay. So Clyde is orange, ink is cyan. Did I do it wrong? Clyde is orange, ink is cyan. Clyde. Oh, I think this So Clyde needs to be there and this there because orange was last. Is this correct? Yeah, the last one is orange and then sign. Okay, yeah, thank you. All right. What was that message? Okay. Yeah. So we need to calculate direction somehow. So direction is calculated in some way or another. We're not gonna rotate by direction. We want to get a direction like a, what is it called? Is it called a cardinal direction or is it called a orthogonal? I'm not sure what it's called. Not 8 directions, 4 directions, cardinal direction, I think. So we want to get the cardinal direction somehow. And then based on that, we're going to choose a different, offset. So I'm just going to make a thing here, cardinal direction. I'm not sure if that's what it's called. I'm going to call it that anyway. And it's going to be like up, left, down, right. And we're going to get an offset here. It's going to give us a offset vector, return, switch on self. If we're up, so basically if we're right, that's going to be 0. And then we have like up, left, and down. And then the idea here is that we're going to have another offset that is like the first in the animation here is going, this is 0, that's the first one, okay? And then we have down is going to be like the next one over. So this one started at 35, that's exactly 34 pixels over because it started 1. So it's going to be 34 in X, that is down, 34. Isn't that perpendicular though, pac-man? Doesn't perpendicular mean that? Or am I crazy? I thought orthogonal was like, I don't know, man. I don't know. Anyway, so this should be plus 34 again. So it's just 34 over, right? So the next one over is left. So it's 34 times 2. And then this is 34 times 3. So there we go. So there's our offsets for that. So in order to get the actual correct the correct source rectangle, we need to take the original animation location. We need to add the offset of the direction and the offset of the palette to get the correct renderable. So what we're gonna do is somehow we get the direction based on the velocity, or we could probably just set the direction on the ghost, I guess. Or they just have a velocity at all times. And we can base it on that. Cardinal directions are 4 primary points on the compass used for navigation and mapping. North pole. Yeah, exactly. That was what I thought. Orthogonal semantic sets as well as state in geometry. Okay. Well, from velocity or something. Let's.
Okay, I'm just gonna choose up for now. Okay. And then down here, we're gonna say like cardinal from velocity. And we need to get body. So I'm gonna include body here. We don't need to, but I'm gonna do it anyway. And then body velocity just for safety. So that gives us the direction. And we also want to get not the animation, but we want to get the renderable. Not the const version though. We're going to get the actual pointer. And then we're going to set the current rectangle. Actually, we do want to get the animation as well, because that's the starting point. Animation. This is the starting point. Actually, it resets every frame. Actually, yeah. So we don't need to do that. So we're gonna get the rectangle because that's freshly set from the animation, and then we're gonna set the no, not rectangle. It's sprite. Then we're gonna set the source rectangle x is gonna be plus equals to the direction offset dot x and also the palette offset dot x, and then y is gonna be the same thing. Okay, now we need to get the direction offset. It's just gonna be direction dot offset, and then palette offset. Gonna be ghost palette dot offset, but we don't have ghost, so we can just grab ghost like this. Get, you don't need to be a pointer, so we get the ghost from there. Body can be a constant. Renderable is the one we want to change. Okay, there we go. So that should like put it at the correct thing. Now in order to test this, I'm just gonna, oh, we have a 3A. That's a new one actually, 3A. I've never seen that before. We're going to well, first we need to add this system here and stuff. So let's add the ghost system. Also, when we create a ghost, we should add the ghost component. And we need a palette, so this is the palette here. So we can actually pass a palette in here. And so we'll create, I guess we'll create all of these ghosts here. Clyde, Pinky, and Stinky. No, Pinky. That's right. All right, and then oh yeah, this is this. What else are we doing here? Yeah, I guess we'll add like the position. It's gonna be slightly different though. We'll just do this. I'll just do y is gonna be plus int from enum palette times 32 or 16 or something. 24. Sure. Or 30. However, I need to like convert this here, so f palette is gonna be f32. It's gonna be float from int from enum palette. Okay. So they get different positions based on what the type of their thing is. Okay, they should all have the same graphics now. Okay. But when we call the ghost update, we should do it after animation. The ghost system update. Now their graphics should update to be the corresponding thing. And they should all be pointing upwards. There you go. Except they're not pointing upwards. Okay. Why is that? Did I map it wrong? But yeah, it basically works. The basics of it works. We just need to modify where the direction offset. Up is 34 times 2. Hang on. This is 0. This is 1. 1 is down. 2 is left, and 3 is up. Oh, it's the other way around. There we go. Now they should be pointing up. Okay, there we go. So, cool. Now, I want them to have some kind of velocity. So I'm just gonna do like basically, let's just make them move. Let's make them move in like a random direction or something. Or like, yeah. So based on their palette, I'm gonna make them move in a certain thing. So we're gonna rotate the velocity. We're gonna set you to be init 1 0. Rotate. Except you can't do it like that. You have to kind of do this. Actually, let's just do init 1 0. So it's pointing to the right. And then we're gonna, whoops. And then I'm gonna set you to be, to rotate. And the rotation will be palette. So 0, 1, so we have 4 different ones. And I'm gonna rotate you by pi over 2, right? That should be 90 degrees, if I remember correctly. You are now not a constant anymore. Okay, so that should make them move around a little bit. Actually, they should be, they're gonna be very slow, but like 1 pixel per second. But they are gonna move around, maybe not. What is the speed? The speed is like 100. Okay, let's do 25. Okay, let's just add 90 degrees here, because it seems like they need to orient themselves. All right. There we go. Okay, we can see them move at least. Okay, so cool. Now I want to so all of them are moving in their each direction, right? So I want to be able to calculate from the direction they're moving. I want to like get a cardinal direction, right? So we're gonna do, and it should always be almost exactly in one direction. So what we can do is we can get, so we have the velocity, we can get the rotation from arctan 2, and we can say velocity y, velocity x, and then we're gonna do if, then there's like equal, approximately equal, and I don't remember what the difference of these was. Perforce an approximation of two floating point number x and y. Returns true. The absolute difference between them is less than or equal to the specified. Oh, I see. Absolute. Okay. So we should do like absolute, yeah, because that's gonna be like in either direction. It's gonna be smaller than or whatever. So we're gonna do like this one, because this is like when you're dealing with floating point numbers, and it's like you're slightly off, but you still wanna consider it equal, basically. You can use approximate equal, and the first is going to be r, and the second is going to be pi. Well, we can do 0, and the tolerance, you can choose the tolerance here. I'm going to choose like some small number, 0.1, because that's going to be, I think, more than enough to be able to calculate this. So if this is true, that means we should be to the right, because 0, the angle 0 is right. Otherwise, we have approx equal relative, or I mean absolute r. And then the next one is pi over 2, that's 90 degrees. Tolerance, that should be up. Otherwise, we have pi, that should be left. And if that doesn't work, we should always be down. Okay, there we go. Now, I'm gonna, we might need to change this, so I'm gonna put this in a thing here. Okay, cool. There we go with this again. Okay, so now the direction should be different for each one. The direction should be mapping in the direction they're trying to move. Hopefully. There we go, except it's not quite correct. The one that's going left is pointing down. Strange. Left is pointing down. Did I do wrong here again? Down is 1. Left is 2. That's 3. Yeah, that looks correct. Left is, this is 180 degrees. That's to the left. Right is 0. This is 90 degrees. That's up. Unless this is the other way around. This could be like down. But that doesn't make sense anyway, because this one was looking down. So also, I'm not sure how this one got stuck like this. But okay. Why is that happening? Why is that happening? Wait. Alright, we changed the velocity, and then we calculate this. But that shouldn't matter, because this should stick until next frame, so they're gonna be like the first frame they have the wrong thing and then they change. Okay, well, let's just do this. So what should they have? Blink is looking up. Pinky is looking right. Blinky is the first one. It's looking up. It makes sense because this should be 0. This is the rotation we're setting them to have. This is 0, and then this is 90 degrees, so that should be up. So that is correct. However, it could be down as well, but it doesn't matter. And then the next one is orange. Should be looking left. Which it's not looking left, but it's moving left. I mean, I guess we could change the tolerance. The tolerance is gonna be something like, maybe 0.1 is too much. No, that can't be too much. Let's do like 0.05 maybe. Because down is like the fall through. .3. Feels like it's too much. Maybe it's not. No, it's still the same. So 0.3 is like pi over 10. Even less. So that should be a good thing to use. Let's do this. Let's go to draw. Let's do it like a debug thing. Let's draw their velocity as like an arrow. So we'll get the sure, let's get the hitbox. Let's get, well, yeah, let's get the hitbox, and then we'll draw, I'm gonna say draw arrow from start position is gonna be hitbox hitbox X, hitbox Y, and size is hitbox width, height. Well, this is top left. So this is going to be top left plus size over 2. That's the start. Okay, and then the end is gonna be start plus body velocity, and then we'll scale it maybe. No, let's just have the velocity there. Yeah, that's the end. So then draw arrow So first we want to draw a line. I'm gonna use this. So start and thickness gonna be 2. Color is whatever. I'm just gonna choose white. Okay. And then we're gonna do like, I don't know. We don't really need to make an arrow, but let's just do it for fun. Start at the end, and then we'll have like a line going out. So let's make this, let's get the diff is gonna be end subtracted by start. And then we're gonna do, we'll take that. So we'll take like the arrow end. It's gonna be diff. We're gonna scale it by maybe 1/4 of the size or something. And that's gonna go from start to end. That's the relative from start to end. So we want to rotate it first by, now let's do, yeah, arrow end, we rotate, I guess like 45 degrees or something like that, times, no, over 4. And then we'll do it the other way. So basically just math pi over times 2 minus that. Right, that should be good. Hopefully. Wait. Oh yeah, we need to also add start. No, we need to add end. Because those are relative to the thing. So end, add. There we go. It's gonna go the other way, I think. It's gonna go like, I'm not sure. Yeah. Well, we can't see where they go anyway. So let's do, this should get rotated, I guess 3 times. Yeah, let's do it like that. Okay, we can see that well, we can see a couple of things. Up and down are reversed. Right works, left doesn't work. But we do see that they do have like a velocity and stuff there. And yeah, you can also see that Pac-Man has a velocity as well. Okay, cool. Now, so, why is that happening? So up and down reversed. So let's just say this is down and this is up. This is going to be 3 times this over 2. Then we move up. Otherwise, it's kind of like some default that we choose here. So we could make it like optional, but that doesn't make sense. Like, but let's just do right as a default. Suddenly Pac-Man gives a chainsaw my lives. Yeah. Like having it like Pac-Man with a weapon. Okay, yeah, because now you can see this guy is actually looking to the right. This is also looking to the right. The only one that's actually correct is like this one and perhaps this one, but it's like it's hard to tell. This is weird. Does this actually work as I think it does? Approximate comparison to floating point values x and y. Turns true the absolute difference between them is less than or equal to the specified tolerance. Right? So it's going to take like r minus pi over 2. So the difference of the absolute value should be less than or equal to the tolerance, which is the thing that I want to happen, but I'm not sure what's happening here. What we could do is say from well, actually what we could do is we could say, okay, well, let's say the direction, let's do a debug test here. Let's say the direction is going to be enum from int, and then int from enum, and then this is going to be ghost palette. So essentially converting between the two enums where, well, depending on the ghost, we're going to just choose a direction here, and your cardinal direction. So there's going to end up being the same, well, because they have the same, they're each 4 different values in the enum. That's going to be able to map through there. Okay, so we can see that the directions themselves work. Like the cardinal direction offset does work. So we are able to map that. But there's something wrong with the calculation here. Also, I'm just going to make sure that the directions are correct. So the first one is, I'm going to have to go over to ghost. Blinky should be up. That looks correct. Clyde should be left. That's not correct. No, wait, that is correct. I think. Yes. Inky cyan should be down. That's correct. And then Pinky is right. Okay, so all of them are actually the correct, like the cardinal direction. This offset is correct. It's this function that's wrong for some reason. And the velocity is correct. It's only this conversion here which is wrong. I don't understand why. I see why they made Pac-Man to move only in the cardinal direction, because of that. In that word you can only move in these 4 directions, otherwise you look silly. Come on, it's cool. It's like free rotation. Like Pac-Man using vector graphics would be pretty cool, right? Like when vector graphics, did they ever do some kind of you know, zooming in and out? Wouldn't that be kind of easy to do? Maybe not, because you had to kind of, then you would have to add a multiplication to every coordinate. And those weren't floating either, maybe. Like, why can you rotate 45 degrees if you can never walk in that direction? That's what I mean. Yeah, I mean, true. I'm keeping it just because my intention was to just be able to show the 4 different directions, up, down, left, right. But it ended up, there's a bug right now, which makes it so it doesn't look like that. So, but yeah, I'm not gonna fix that right now. Maybe I'll just keep it this way because it's funny. What do you think about that? No, but yeah. Why is this not working? Why is it not working? God damn it. Yes, exactly. It's a feature. Like, because all you do is take or x minus y, absolute it, check if it's less than or equal to tolerance. So x minus y. So let's say x is close to 0, y is 0, tolerance is 0.3. If this is 0.01 or something, the difference should be like negative 0.01. Or no, it should be 0.01. And then the absolute 0.01 is less than or equal to tolerance. So that should be true. I don't understand. And then it seems to only work for the right one. No, for the down. Yeah. And then this doesn't work for some reason. Yeah, this one we know does not work. Why? If r is close to pi, it should be true. Pi over 2 is like 1.5. 3 times pi over 2 is like... Yeah, so the tolerance should never short circuit onto right. I don't know, let's do like 0.01. Yeah, if I only could add breakpoints, I actually can't right now. Okay, but yeah, I'm out of time, unfortunately. I'll probably come back to this on a day 3. I just want to I actually want to complete this first wave because it's such an interesting game. So that's going to be it for this time. So thank you very much for watching, and I'll see you next time. 1 second. All right, so I'll send you off here. Twitch-ins. Raid. I think I need to refresh to get like the latest ones. Yeah, Zig does have like you can debug with GDB, I think, or LDB or something like that. But I've had trouble setting it up with NeoVim and stuff like that, and it's not like a perfect. But you can do it. I just haven't done it that much, and I usually just try to log stuff out instead, most of the time. Let's see. Like I know how to debug. It's just that the tooling, there's no like official Zig debugger or something like that. Where can we go? Okay, so yesterday I accidentally sent you off into someone spoke French, so I'm trying not to do that this time. Let's send you over here. Okay. Yeah. Bye-bye. Thanks.